Who? No, that's a 3. That's a twins. That's just a twins. Everybody, okay. All right, if vector v, so we don't have to say hi to anybody today, huh? Equal to a subscript 1 in the I direction plus b subscript 1 in the j direction, and vector w equals a2 in the I direction plus b2 j, okay, if these two are given to us. The dot product of two vectors formula. When we say v dot w, v, oh my gosh, I keep writing w. V dot w, that's how it is read. V dot w is a1 times a2 plus b1 times b2. This is the formula for the dot product. And guys, your answer is not a vector. Answer is not a vector. Okay. So, yes? No, it's going to come out to be just one scalar, one number. Properties of your dot product. Dot product is commutative. So that means if you have v dot w, it's the same thing as saying w dot v. It is distributive. Distributive. That means if we have three vectors, u dot v plus w is the same thing as saying u dot v plus u dot w. It also has a zero dot product. Zero product. So if you have vector 0 dot vector v, you will get vector 0. And the last one, just to kind of be mindful of, is if you have v dot v, it is going to be the same as finding the magnitude of v and squaring it. Okay, so up to this point, I know we use tangent inverse a lot of y over x to find the angle. Would you guys agree? But that angle would only work if you have a vector that starts on the x-axis. Does that make sense so far? What if two vectors are not at all on the x-axis? Because vectors can be anywhere. So to find find the angle between two vectors, we are going to come up with a different formula for that. So if v and w vectors are non-zero vectors, the angle theta is restricted between 0 and pi, including both, okay? Including both ends. I mean, what quadrant is that in? Only 1 and 2, okay? So theta is restricted in 1 and 2 only. Between vector v and vector w is determined by all right, here comes the formula. Cosine of theta equals the dot product of v and w divided by the product of their magnitudes. So this is what we would need to use to find the angle between two vectors. As you can see, it's given to you as cosine of theta, but if I said find theta, what would you need to do? Yeah, so you crunch out all that number to the right, and then you have to do cosine inverse of that number on the right, okay? Parallel and orthogonal vectors. Parallel or parallel. If you have two vectors that are parallel, what do you think orthogonal is going to be then? Perpendicular. You're right. Fancy word for perpendicular. Okay. So parallel vectors and perpendicular. These are the characteristics of those, so we can find them. Bullet number 1. Vector v and vector w are parallel if there is a non-zero scalar, let's call it alpha, so that, bless you, so that v equals to scalar times vector w. Okay. If this is true, the only difference is the scalar, then these are parallel to each other. In this case, the angle theta between w vector and vector v is either 0 or pi. Sometimes you don't realize that the difference is just a scalar. So if I ask you to find the angle between the two vectors, and it comes out to be either 0 degrees or 180 degrees, then you immediately should know that these two vectors are parallel. Okay. So that's how we know. Oh, it's either. I forgot an R. Okay. The rest, these next two dots will be for your orthogonal. If the angle between two non-zero vectors, v and w, if the angle between two non-zero vectors, v and w, okay, if the angle between two non-zero vector v and w is pi over 2, aka 90 degrees, okay, then guess what this would be? Yep. Then v and vector w are orthogonal. I'll take this upside down t if you don't feel like spelling out the word orthogonal. Next bullet. Okay, so this is sort of a comprehension here. If I do the dot product of the two, so I'm going to take w and do the dot product to w, v and w, and it gets to be 0 vector. Okay, so do the dot product equals 0. Then by the 0 product property, would you agree that either vector v is 0 or vector w is 0? Would you guys agree with that statement? Okay. Do the dot product equals 0. By the 0 product property, one of it is going to be 0. So here's my question for you. If I ask you to find the angle, which I'm about to use cosine formula, right? Cosine formula is the dot product divided by the product of their magnitudes. But if the dot product is 0, what is cosine of theta really? It's going to be 0, right? Because the dot product is on the numerator. So if the numerator is 0, I don't care what the bottom is supposed to be. It's going to be 0. Well, so cosine of this is going to be 0. If cosine of this is 0, what is theta? Theta is 90 degrees. Okay. Therefore, whenever you guys are doing the dot product, and it equals to 0 right away. You don't have to go further. You should be able to say that those two vectors are what? Yep, orthogonal. Okay, so now that's pretty much all of the characteristics of orthogonal. But I just want to make this one last remark. 0 vector is perpendicular, aka orthogonal, to every single vector. Is orthogonal to every vector. You're not going to see 0 vector a lot, but you ever do, and that's always true. Okay. Writing vectors in terms of its magnitude and direction. This is a review. If I give you the magnitude and I give you the angle, which is the direction, how do you go backwards and give me the vector? What did you do? What's the formula from yesterday? Vector v is,
The magnitude is v times the cosine of
whatever that is, right?
Yeah, theta I plus sine of theta.
Yep.
Sine of theta.
Yep. So horizontal and vertical. Perfect. Right, so this is the last definition for this whole unit. And I want you to put your pencils down once you're done, because I want you to understand it first, and then we can copy it. Because we have to understand this formula for us to apply it to all of the applications in the future. Because the wording is a little bit funky, okay? So put your pencils down. I will give you all the time you'll need to copy it later. Projection of a vector onto another one. So if I give you, so here's the wording, and we're going to dissect each sentence. Suppose vector v and vector w are two non-zero vectors with the same initial point. Okay. So I'm going to graph this out. Every sentence we do, I'll just break that down for you. And again, don't copy it, just try to pay attention. So here's a coordinate plane. Because vectors, I can start anywhere. Where do you think the easiest part for us to start? Yeah. So I'll start here. Here's vector v. All that first sentence said is the same. So I can put it anywhere I want as long as it starts the same. Here is vector w. Would that be okay? Is that true so far? Perfect. Let's move on to the next sentence that they have. Okay, v is decomposed. So the next one is that, okay, take v, vector v is decomposed. Decompose is another word to break it down. Would you guys agree? Break it down into v subscript 1. Okay. Ready? And v subscript 2. Okay, I'm gonna hold it tight. What does that mean? It means I'm gonna take my original vector, which is in that pretty color right there, and break it into 2. But with these two vectors, v1 and v2, when I add them up, it must be back to the original. So what that means is, okay, would you agree that just based on addition of vector, would you agree that this is v1? If I take v1 and I add v2, would you agree that is a true statement? Perfect. Would you agree right now, v1 looks pretty darn parallel to what? W. v2 looks pretty perpendicular to w, orthogonal. You're right, okay? So here's a formula to get to v1. v1, and again, don't copy it out. v1 is the dot product of the original v and w divided by the magnitude of w square times vector w. I know, so intense. And v2, once you get v1, v2 is just simply, bless you, v minus v1. Okay, so don't copy. That's how we get v1 using w. Now, And then as you can see, V1 is parallel to W, and V2 is perpendicular to W. This is the language that we use, or they use. We call V subscript 1 is the projection of V onto W. Okay, so on the homework or on the test, it says find the projection vector of V onto W. That's really asking you to find what vector. V1. Right, write that down. Our next example, example 1. Can you help me with example 1A, please? Evan, what does example 1A say?
Find the dot product. It's up to the dot.
Yeah, what's the formula of dot product, guys?
A1, A1, 2 plus B1, B2.
Right, A1 times A2 plus B1 times B2. And I already gave you two vectors, right? On the bottom there, given V is negative 2i plus 12j, W is positive 2i plus 3j. So go ahead and write the formula down on 1A. During the notes of your homework, you want to write it all down. So by the time you get to your test next week, it's all right here in our brain. once you have the dot product, it's not a vector. Can you guys all agree? Comes out to be a number. Can you compare that number with your buddy? Yeah, leave it as an exact, okay? You don't need to punch it in or anything. Final answer? 32? Okay, let's check really quickly. The formula for dot product is going to be A1 times A2 plus B1 times B2. A1 is -2, A2 is 2 plus 12 times 3. Yes, no, maybe? Okay, yes. That's going to be a -4 plus 36. Therefore, dot product is positive 32. Beautiful. Find the angle between V and W. Formula. Oh my, all of these formulas. Caitlin, start with cosine of theta is. Can you give me the angle formula between two vectors, please? It's actually red a dot, hun. So the dot product of V and W. Okay, divided by? Divided by the magnitude. The product of their magnitudes, yep. The magnitude V times the magnitude W, okay. Perfect. Do we already know the dot product of V and W?
Yes.
Yes, see? So nice. So now we just have to calculate what? The magnitude, yep. So the dot product on the top is 32. The magnitude of V, let's calculate. Formula for magnitude, anybody? Square root of?
A squared plus B squared.
That's right. Okay, I just have to do it twice. So A for V is -2, close that square. B for V is 12, so 12 square, close that up. A for W is 2 square, and B for W is 3 square. So now this gives us cosine of theta equals 32 divided by, okay, on the bottom, woo. 2 square is 4, 12 square is 144, 4 plus 144 is what?
148.
Okay, 148. There are two different radicals. Can I put them together in one radical?
Sure.
Yes. 2 square plus 3 square is what? 13? What's 144 times 13?
148.
I'm sorry, what's 148 times 13? Thank you. Some big, ginormous radical.
1924.
1924. 1924. I don't really need to simplify that because that's not my end result. My end result is finding what? Theta. So how do we find theta? That's right. So
32 on top.
32. Thank you, Tim. Theta equals cosine inverse of 32 divided by some square root of 1924. All right, enter. You definitely need to use calculator. Enter that in. For consistency, how would you like to round today? Second, 2 places? Perfect. Borrow a calculator, get a calculator, enter that in, please. Steal a calculator. Come on down, I have 10. You may steal one from me for today. Yeah, keep it in degrees.
You're so lucky.
Yes, please, take one. Is yours dead?
Yeah.
Oh, okay. Okay, so I was told to keep it 2 decimal places. Dean, whenever you're ready, hon. What is the angle between these two vectors? 43 point what? 15 degrees, okay. Do you guys agree with Dean? Okay, box that up. Next part, technically, if you didn't have to find the angle already, you would have to find them. C says state whether the vectors are parallel or orthogonal or neither. What would you say? Neither. Okay. When would it be parallel? Good. So parallel if theta is 0 or 180. When would it be orthogonal? 90. Okay. Orthogonal if theta is 90. I'm just spelling it out so that way you know when you look at your notes. Example 2. Chris M, can you help me read example 2, please?
Decompose vector v into two vectors, v1 and v2, where v1 is parallel to vector w, and v2 is orthogonal to vector w.
Oh, now you get to use that long formula, right? It says take v and decompose into two. One's called v1 and one's called v2. So let's write the formula for v1 first. What's the formula for v1? The dot product of v and w divided by times it all to
Vector W.
that's right. Perfect. Look at these two vectors that's given in example 2. Are they identical to example 1? Oh, that means, do we know the dot product? Yes. What is it?
32.
That's right. See? Like I said. All right. Do we know the magnitude of W already?
Yes.
We computed it earlier. It was, that's right. Whoa. I meant to highlight that. Okay, so that's rad 13. Okay. So what happened though when you have a rad and you square? That's right. You're going to be so amazed later. All right. And then times whatever W is happened to be 2i plus 3j. And no, you can't leave it like that. You got to make it really pretty. Okay, ready? We know rad 13 squared, that's just going to turn out to be 13. So this is 32 over 13 times 2i plus 3j. Let's distribute the 32 over 13 out to give us v1. Okay. So v1, final answer is 32 times 2 is?
64.
64 divided by 13. Leave it as exact. Plus 32 times 3?
96.
96 over 13j. Perfect. That's v1.
We simplify it.
You should always simplify when you can, definitely. So it said take your original v, decompose it, make it two vectors now. We got v1. How do we get v2? Subtract.
Vector V minus vector V.
That's right. All right. v2 equals v minus v1. We have both. That means v original was negative 2i plus 12j. That's your vector v. Take away 64 over 13i plus 96 over 13j. True or false?
Sure.
Should we make v into a common denominator 13? Yeah, okay, let's do that. So this would need to be something over 13i plus something over 13j. Okay, so, and then I'm just going to get rid of the parentheses. So that means this is now a negative 64 over 13i, and this is now a negative 96 over 13j. All right, so go ahead and find your v with a common denominator of 13. So Emma, whenever you're ready, give me the new numerator for I, hun. Negative 26, okay? Give me the new numerator, Kristen, for J. 156, like that? Okay. Those are right? Perfect, let's combine. Final answer, ready? V2 is 26 over 13i, take away 64 over 13i, we should have?
Negative 90.
Negative 90 over 13 in the I direction. Then you got 156 over 13j minus 96 over 13j. We now have a positive 60 over 13j. Okay, those are the two. We decompose them. Now, which one is parallel to W? V1. Okay, V2 should be perpendicular to W. Okay, so why is that important? Because we're going to use it right now in this application.
I know the answer to the joke.
What?
Isn't that a joke right there?
What's the joke?
The one in bold letters?
Oh, yeah. I need to keep my kids safe, right?
Yeah.
Oh, yeah. We're going to do it, we're going to use math, the projection method to calculate this, and then we'll do it the physics way. Okay. One error though, can you change this 20% to 20 degrees? Okay. Example 3, ready? Can you help me? Tim, help me read example 3.
Example 3. A wagon with a set of triplets as occupants that weighs 120 pounds is on a hill with a grade of 20 degrees. What is the magnitude of the force that is required to keep the wagon from rolling down the hill? Alright, the question is pretty easy, right? What do I need to do to keep my triplets safe? Use your technology to search for what is a force and write down the definition that makes the most sense to you.
If you already know it, you can spit it out. What's a force?
Something that moves.
What is it?
Power.
Power. What else? Energy, right? The force is energy.
That was a joke. It was a triplet.
I do have triplets.
I thought it was like centripetal force. I don't know.
Force is energy, okay? Power that you need to exert. All right. Here's the, who already studied this in physics? Okay. Find the force, right? Okay. So here's the math behind your physics. Draw a picture. Yes, we will. We will have a hill, not totally drawn to scale whatsoever. How steep is this hill?
20 degrees.
20 degrees. Perfect. Back in the days when my kids were little, I used to have a 3-wagon, and then I pull them around the neighborhood. Can't hold them. I don't have 3 arms, y'all. I just use them, pull them around. I live on a small hill, so go up and down was tricky. Okay, so this is true.
Wait, 3 wagons or 1 wagon?
It's a 1-wagon, but it has 3 things attached.
Oh, okay.
And I would just walk around my neighborhood. Okay. So a couple of things that we want to write down. Because it's the first time, if you are not in physics, first time we're doing this. First, I will give you vector W. Vector W goes this way. Okay. Vector W, and then I'm going to write it out right here. Vector W is the vector that's just simply parallel to the hill.
Wait, are we using friction?
To the hill. Right now, it doesn't say so. So, okay. All right, so W is just a vector that is parallel to the hill. Would you agree that we don't know the magnitude or the length of this vector or the hill? So, because we don't know, then we don't need to worry about the length of it. The vector W is simply cosine of 20 degrees in the I direction plus sine of 20 degrees in the J direction. So that's the vector of the hill. We do not know the length, so that's why we don't have the magnitude in the front. Next, I'm going to give you another vector. Anybody know what this is? What force goes straight down? Natural force, gravity. Okay. Now, your gravity, because the kid's total weight was 120, that's the magnitude. And it's downward, so that's a negative 120 in what direction? J direction. So, vector F is the force of gravity. Is the force of gravity. Okay. I'm going to make up another vector. Let's call this vector V. Yeah?
Oh, vector, okay.
Vector V. Making it up. Vector V is the force that's causing the wagon to what?
Roll.
Roll. Bless you. To roll. Okay. So, just to kind of get a background, the force that's causing the wagon to roll would be the same amount of force that will keep the wagon in place. They're just opposite what? Directions, yeah. So something that's causing something to roll is the same force that will hold it in place, right? Prevent it from rolling. Does that make sense so far with how that works? So negative V would be the force from preventing it to roll. So that's how vectors are used to manipulate this. Okay, so we got everything spelled out. We're going to do the math way first. Determine the vector projection F onto W. Well, earlier we did the projection definition and we wrote that V1 is the projection of V onto W. Well, we don't have V1, we have F and what? Yeah. So we have to rewrite this formula to kind of match up with a new vector name. So we'll write the old one first, okay? Earlier, the old one said V1 equals the dot product of V. This is your old definition, and we'll take out variables and replace it with new ones. So earlier's definition was this. Okay. As you can see, this definition is the projection of V onto what? W. We have F. See this right here? So all we're going to do is take out the V and put in F, okay? So F dot W is still the same, right? Over, this is still the same. And then this is still the same. But what would this equal to? Remember, V1 was parallel to which vector earlier in the original? W. Now let's look at our drawing. Which one is parallel to our W based on this drawing?
V.
Yes, this equals to V. I'm gonna hold it right there. Are we okay with replacing that out? Okay. So if I can find this vector, I can find the magnitude, then that would be the force that is preventing from rolling. Okay, all right, let's do it. All right, dot product of F and W. Dot product is A1, what? Times A2 plus B1 times B2. Well, A1 for F, do we have any? Nope, that's 0. Okay, B1 for W is cosine of 20 degrees. We'll leave that for now. Plus B1 for F is a negative 120 times sine of 20 degrees. All over. Okay. Would you agree that's a formula for dot product? Now, let's find the magnitude of what? W. The magnitude formula is what? The square root of A squared plus B squared. But this formula says I need to square my magnitude. So what is the A value for W? Cosine of 20. So would you agree I write cosine square of 20 degrees? Plus what? Sine square of 20 degrees. What? What is that right away?
1.
Whoa. That goes straight to 1. Look at that. I don't need to worry about that later. Okay? Now I'm just going to multiply this to my vector W. Okay, this is the math behind the physics. And then when we do the physics, whatever way your physics teacher taught you, you go connect the two. Okay. So a couple of things are going to be canceled. Would you agree that obviously this will be gone? The bottom is 1, so do I need to even worry about it? No. So vector V is pretty nice. It's negative 120 times sine of 20, and then close this up with cosine of 20 in the I direction plus sine of 20 in the J direction. Okay. Now I would like for you to use your calculator and enter it in and give me this right here.
How did they get over there?
I don't know.
It was right here.
You go.
What is that number? Should be negative. Negative 41.04. Thank you. And then cosine of 20 degrees in the I direction plus sine of 20 degrees in the J direction. Now I'm going to highlight this because we want to talk about this. Would you agree that this is a vector of V? V is the force that's what? Causing the wagon to roll. That should be the same force that's going to prevent it from rolling. Would you agree that if I gave you a magnitude, you can go back and write it as a vector, a magnitude and an angle? So if you have this, should you know the magnitude right away? What is the magnitude? 41.04. Okay, so the magnitude of V, when you have it in this format, guys, the magnitude is the number in the front. So 41.04 is the magnitude. What is the unit of measurement for force? Anybody know from physics? Well, in physics, yeah. In here, though, because I'm giving my kids as pounds, it's just what? Pounds. Okay? So it's 41.04 pounds of force. So the unit is pounds. Yep.
You said in the formula 41.04 is the magnitude. What formula was that?
The formula that finding a vector giving your magnitude and directional.
Oh, okay. So
Yeah. All right, that will be for good today, obviously.